Today, let's learn how we can use the electron configurations in order to identify the properties of elements. If you are going to write all the electron configurations of all the elements, you will notice that the elements on this side have the s orbital as the last orbital in their electron configurations. The elements on this side have p orbital as the last orbital in their electron configuration. These elements have d orbital as the last orbital, while these elements have the f orbital as the last orbital in their electron configurations. So it goes like this. You have the s block, the p block, the d block, and the f block. Now we can use these blocks to identify the properties of elements. Let's begin with the s block. The s block is composed of this set of elements. Basically, you have two columns for the s block. The first column is what we call the alkali metals. Now, in this list, we exclude the element hydrogen. Please take note of that. The elements under the alkali metals have the following properties. They are shiny, they are solid at room temperature, they are very reactive, and they are good conductors of heat and electricity. The other column is what we call the alkali earth metals. These metals have almost the same properties with alkali metals, but with different variation. The alkali earth metals are shiny and silvery in nature. They are solid at room temperature. They are less reactive than the previous set of metals, and they are also good conductors of heat and electricity. Now let's now move on to the p block. So the elements here have the p orbital as the last orbital in their electron configurations. So the p block have the following set of elements. Now, if you want to know, just for the record, if you want to know the names of each column, it goes like this. The column under boron is called the boron family. The column where carbon is located is called the carbon family. Then the next one, yes, you're right, it's the nitrogen family. Now, to continue, we will now focus on the last three columns. The column where oxygen belongs is called the chalcogens. Now, chalcogens, most of them are metalloids, except for oxygen and sulfur, which are nonmetals. Now, likewise, except oxygen, all of them are solid at room temperature. Oxygen is, of course, gas at room temperature. Now, all of them are reactive. The next column is called the halogens. Halogens are all nonmetals. The elements fluorine and chlorine are gaseous at room temperature. Bromine is liquid at room temperature, while the other three are solids at room temperature. Now, of all the elements on the right side of the periodic table, the halogens are the most reactive elements, because the last column, which is called the noble gases, are called inert gases. Now, inert gases means to say they are non-reactive, non-metals, and they are gaseous at room temperature. Now, let's proceed to the other blocks. The other block is what we call the d blocks. This is basically the elements listed at the middle of the periodic table of elements. The d blocks are composed of, or is composed of, the following list of elements, and they are called transition metals. Now, if you want to be more specific, the elements from scandium up to manganese, they are called as early transition metals, while the ones from iron up to zinc are called late transition metals. Now, all of them are metallic in nature. They are solid at room temperature except for mercury and copernicium. And these elements have high melting and boiling points, meaning to say, if you want to boil or melt them, you need a tremendous amount of energy, heat. Now, let's now move on to the last block. These elements have the f orbital as the last orbital in their electron configurations. And this block is composed of the following elements. They are called as lanthanide and actinide metals. Now, the first row is called the lanthanides because the first element in the row is lanthanum, while the second row got their name from the first element in the row, which is the actinium. Now, all of these elements are basically soft and silvery metals. Most of them, rather all of them, are solid at room temperature, but their obvious differences is that lanthanides are non-radioactive metals, while actinides are radioactive metals. So that's how we can use the electron configuration in order to identify the properties of elements. I hope you learned something today. Good day and God bless you.
Tell me pretty lies, look me in the face, tell me that you love me.